This is the first in a series of videos on graphing rational functions from an equation. So, the thing is that rational functions have a lot of things going on at once. Roots, y-intercepts, holes, vertical asymptotes, and horizontal and slant asymptotes. Let's just remind us how we find each of these things before we dive in. This is by root is when y equals 0, so we set y equals 0. For a y-intercept, we set x equals 0. For a hole, we look at um, factors of the numerator and denominator that cancel, and that will give us where the holes are. The vertical asymptotes are the other factors of the denominator, and the horizontal and slant asymptotes are the result after we perform the division. One thing that's worth pointing out is that when we actually perform the factoring, that will also find us our roots. So it's good to start with the factoring, in my opinion. So let's do a first one. Let's graph f of x equals x cubed minus 16x over 3x squared plus 6x minus 9. So let's factor. We get x times x minus 4 times x plus 4 is the numerator, and the denominator is 3 times x plus 3 times x minus 1. So let's go through things one by one. We have our x-intercepts, or our roots. So if you look, nothing cancels between the denominator and numerator. So our roots are 0, 4, and negative 4. Our y-intercept, if we plug in 0 into this, we'll get 0 times negative 4 times 4 over 3 times negative 1. So that's 0 over negative 9. So 0 is our y-intercept. For holes, nothing is canceling between the numerator and denominator, so no holes. Let's see, x asymptotes. We have x can't be 3. Oh, sorry, negative 3, and it also can't be 1. So those are our two asymptotes. And then our y asymptotes, or our horizontal asymptotes. No, this will actually be a slant asymptote. We're going to have to divide that out. So that's x cubed minus 16x divided by, I should write that out the long way, x cubed plus 0x minus x squared minus 16x plus 0, all divided by 3x squared plus 6x minus 9. So how many times does this go in? It goes in, let's see, 1/3 x times. And then when we multiply that out, we get x cubed plus 2x squared minus 3x. Subtract that, and we get negative 2x squared minus 13x plus 0. How many times does this go in? I believe it goes in 2/3 times. Yep, it does go in, so negative 2/3 times. Negative 2/3. So that would be negative 2x squared minus 4x plus 6. And then we switch the signs, but it doesn't matter what remainder we get because now we know that our slant asymptote is y equals 1/3 x minus 2/3. So let's use all that information in the graph. So our x-intercepts, 0, negative 4, and positive 4. Our y-intercept we already have. There are no holes. There's an asymptote at negative 3 and an asymptote at 1. And then our slant asymptote is at 1/3 x minus 2/3. So from here, up 1, right 3, up 1, right 3. This is approximately what the graph is going to look like. Now, depending on how picky we want to be, we can plug in more points to find exactly what's going to happen. But for this purpose, it's perfectly fine to just say, okay, that's what it's going to look like up here. We know that it's crossing here and that the end behavior is going to be approaching that. We can tell that this is going to be going like that, and then this one is going up there. If you want to be more careful, you can certainly plug in values for x to test whether things are going up or down here, but this is a good start for how to graph a rational function.